Welcome June 7th LeetCode Challenge. Merge sorted array. You're given two integer array nums1 and nums2 sorted in non-decreasing order, and two integers m and n representing the numbers of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single sorted in non-decreasing order. The final sorted array should be not returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0, should be ignored. Nums2 has a length of n. So basically what we have is the length of nums1 is the m plus n, but the first n elements, m elements should say, are values and the rest are 0. And then when we merge them together with the length of n, which is the number of elements in nums2, therefore we just kind of put all the nums2 into nums1 and then sort it in non-decreasing order. And as such, that is done here, basically. So here, example 1 is pretty much explained. The self-explanatory. Example 2, if we have nums1, which is a value array of 1, and nums2 is empty, therefore the output should be just nums1 only, effectively. Similarly, if we have the size of array 1 here for nums, but it's empty with 0, that means we ignore it, and nums2 has a value, therefore we sorted the array in non-decreasing order. The value of the nums, the merge sorted array should effectively just be nums2, but put into nums1. Our constraints that the length of nums1 is m plus n, the length of nums2 is n, m and n are between 0 to 200, m plus n is the value between 1 to 200, and the index of I and j of nums1 and 2 respectively are between -9, 10 to the 9 and then 2 to 10 to the 9. Come with the following algorithm that runs in big O of m plus n time complexity. So in order to run it in a big O of n plus n time complexity, we need pointers. So let's develop an index I pointer and a j pointer, and we're going to iterate through the merging of the sorted array in reverse order. So nums1 has basically the end of the array is filled with 0, so therefore we're going to merge it from the back. It might be a little bit better. So we have the pointer to I will be m minus 1, pointer to j will be at n minus 1 distance from the reverse. So start the merging from the ends of the list. Next thing we're going to do is find the destination target index to which we will insert into nums1. So say we have a target where we're gonna merge it in the ranges of the size of m plus n, plus n, got a minus 1 as well, actually, this is less, and we're going to iterate in reverse order by decrements of 1. So that will be -1, -1. And this is how we do our for loop. So if the second list is empty, then we have nothing to merge. So therefore, if j is greater than or less than 0, then that means the second list is empty. So that'd be nums2 is empty. Therefore, we just return and do nothing, and therefore just get equivalent of nums1. Now we only merge from nums1 if there are items to the left of the merge. So if, let's say, I is greater than or equal to 0, so we only merge if there are nums from the left side to merge. So if nums1 has something inside, therefore we merge it. And we only merge if we only assert at the target if two values from nums1 and nums2 need to be basically they exist. So that means nums1 index I is greater than nums2 index j. So these are pointers at index pointers I and pointers j. We're going to use two pointers approach, as I said before. So that means we have to update nums1 to be the target range where we're gonna our target destination, and that's going to be nums1 at pointer I. And once we update the pointer, we also have to move the pointer by -1 back. If this is not the case, we do an else statement. We jump into this condition where we have to update nums1, I should say, the target destination. Destination. And that's going to be updated to nums2 and pointer j. And then we also have to decrement the second pointer if we use it. And this should all work out. Alright, looks like it's acceptable for the test. So what we do is excellent, accepted. So time complexity wise, it has a runtime of big O of m plus n, because we have to iterate through the list of, basically the maximum list we iterate through is nums1, which is the size of it is basically m plus n, as also mentioned here as well. It is using constant space, constant extra, without extra space, let's say. So it would be constant extra space. And yeah, it's using basically because we don't return anything. And that is all. Have a great day, guys.